Finally, let's look at second degree price discrimination. So, as I mentioned already, that is the case if a firm faces two groups, but it cannot tell who belongs to which group, or at least it cannot base its prices on that. It is no card it can ask for, or maybe it's simply not allowed to base its prices on whatever information it can observe. So, for example, some consumers are willing to pay a lot for high quality, and some other consumers are willing to pay far less. But also, then there may be a possibility to price discriminate. Okay. Uh, how does that work? Well, the firm may induce consumers to self-select. And as an example, let's take the first and second class on the train. Also, this is referred to as versioning. So you design product lines that appeal to different consumers. Sellers cannot directly identify consumer types, but it can still induce consumers to distinguish themselves. That will be the essence of what I'm going to tell you. So let's go to a classic example, which is a railway company. The monopoly wants to maximize profits, and it offers first class and second class seats. There are two types of consumers, those with a higher willingness to pay and those with a low willingness to pay. And we assume, for simplicity, that those groups are equally sized. And to make matters simple, let me refer to them as the rich and the poor. So the rich have a higher willingness to pay, the poor a lower willingness to pay. And let me also put some numbers on this. So for second class, the poor are willing to pay 6, the rich 8, whereas for first class, the poor are willing to pay 10, and the rich are willing to pay 19. Marginal cost, of course, is a bit higher for first class, so let me assume that it is 1 and 2, respectively. So here is a table that neatly sums up all this information. Okay, so the easiest way forward is to first assume that there is complete information. So, in other words, suppose that the railroad company can perfectly observe who is rich and who is poor. Um, and it is also allowed to base its prices on that. So there are a couple of options. It can choose to sell first class tickets to the rich. In that case, it will charge a price of 19 because that is what they would be willing to pay. Its profits from the rich would be 17. If it sells second class to the rich, it will charge a price of 8 and profit will be 7. For the poor, a similar analysis holds. It can sell first class to the poor. They're willing to pay 10, so its profit will be 8. If it sells second class, it can set a price of 6, profits would be 5. So in this case, it turns out to be profit maximizing to offer first class tickets to both, but charge 10 to the poor and 19 to the rich. And in that case, your profit will be 25 multiplied by the number of people, of course. So this would boil down to perfect price discrimination, right? I can observe who is rich, who is poor. I can adapt my prices to that. Okay, let's go for the more interesting scenario. Suppose that the railroad cannot observe who is rich and who is poor, or it is simply not allowed to charge people different prices based on that information. Okay, now we have to be a bit more precise. So it has a number of options. It can only offer first class, it can only offer second class, or it can offer both first and second class, but try to tweak prices such that the rich travel first and the poor travel second. Okay, what is the best thing to do? To find out, we simply have to go through all these options. That's my table. So, okay, if I offer only first class, I can make sure that the rich are willing to do that, willing to travel that way. That would involve charging a price of 19. My profits would be 17. But I can also set a price equal to 10. In that case, also the poor will be willing to travel. I would earn 8 on each customer group. There are two groups equally sized, so my profits would be 16. Okay, so if I only offer first class, I would charge a price of 19 and only sell to the rich, because then my profits are high. What if I only offer second class? Same logic. If I only sell to the rich, I can charge a price of 10. My profits, sorry, a price of 8. That's this entry. Profits will be 7. If I sell to both, I could charge a price of 6. Profits would be 10. So if I would only offer second class, then I would charge a price of 6, make both people buy, but still the option to offer only first class and charge a high price for that gives me way higher profits. So that gives me that bullet point. If these were my only options, I would offer first class at a price that the poor cannot afford. Okay, but now suppose that I can do second degree price discrimination. So the idea is as follows. I'm going to offer both first and second class, and I try to make sure that the rich travel first and the poor travel second class. Um, okay, let's figure out how to do that. I want the poor to travel second class. So that means that I cannot charge them a price higher than 6. So this is going to be the first constraint. I have to set P2, the price of second class, smaller than or equal to 6. That is a participation constraint. Second, I have to make sure that the rich want to travel. I want them to travel first class. They're willing to pay 19 for that. So P1 has to be smaller than or equal to 19. Another participation constraint now for the rich. But more interestingly, I also have to make sure that the rich prefer first class over second class. What do they get if they travel first class? They get 19, but they have to pay a price of P1. So this is their net utility, their net benefit, their surplus if they travel first class. What if they travel second class? Well, the rich are willing to pay 8 for second class. If they have to pay P2, this would be their surplus. So in other words, the rich prefer first class whenever this is satisfied. And that equality is a bit of a knife edge case, of course. Usually we assume that, well, you could all, to make sure that they travel first class, you could also always decrease P1 by a infinitesimally small number. But for simplicity, we always ignore that. And we just assume that, well, whenever consumers are indifferent, we just assume that they do what we want them to do, essentially, to avoid always having these discussions of setting a price just epsilon. Anyway, to make sure that the rich prefer first class, I have to make sure that this is true. This is my incentive compatibility constant. Also make sure that the poor prefers second over first, but that is always satisfied. So let me ignore that. Okay, so these are my conditions. So I want prices as high as possible, of course, but I have to make sure that these constraints are satisfied. Okay, so the first thing to do would be to set P2 as high as possible, right? If I set P2 high, then this only becomes easier to satisfy. And so that means that I can set P2 as high as 6. This never violates the other constraints. So let me do that. So then the other constraints simplify to P1 smaller than 19. That was this one. And if I plug in a price P2 equal to 6 here, and I rewrite it a little bit, I get P1 smaller than or equal to 17. Okay, so P1 has to satisfy these two constraints. So obviously, I want to set it as high as possible such that both are satisfied. So I have to set P1, there's the one missing here, P1 equal to 17. What are my profits in this case? By setting these prices, I make sure that the poor travel second, the rich travel first class. These are the profits on the poor, these are the profits on the rich. Gives me total profits of 20. And that is interesting because before the previous slide, I had profits of, there they are. My highest option so far was 17. So what I do now actually gives me higher profit. So that is the profit maximizing package. These are the profit maximizing packages in this case. So this is my best option. Some interesting things. Well, the poor in this case end up paying what they're willing to pay. So they get zero surplus. In the literature, that is known as no surplus at the bottom. What about the rich? Well, the rich, they do get a positive surplus, right? They are willing to pay 19 for first class, but they only have to pay 17. Why? Well, because if I charge them a higher price, they would travel second class instead, and I don't want that because then my profit would be way low. So they get a surplus of 2. Why? Because I cannot really distinguish between rich and poor, so that is known as an informational rent. And they get it as the railway cannot observe the type, as I mentioned already. It also implies that profits are lower than if first-degree price discrimination were possible. Yes, in my complete information analysis, profits were even higher because then I didn't have to pay this informational rent to the rich. And indeed, what drives the price of the rich is that they should prefer third over second. Okay, you can actually take this analysis a bit further. That's where things get really interesting. Suppose that the railway, for whatever reason, in whatever way, would be able to lower the quality of second class. And it can do so in such a way that the new willingnesses to pay would be a bit lower. It can get rid of toilets or whatever, make it less comfortable. And then willingnesses to pay will also go down. In this case, would it be willing to do that? So this was the original situation, but now this is the new situation. Okay, let's see how that affects the analysis. So these are my new constraints. P2 has to be smaller than or equal to 5.5. If I want the low to travel, P1 again has to be smaller than or equal to 19. If I want the rich to travel first class, but my incentive compatibility constraint is now going to look like this. 19 minus P1, the surplus from the rich if they travel first class, should now be bigger than 6.5 minus P2, which is their surplus if they travel second class. Can rewrite it a little bit. So I'm now going to charge P2 equal to 5.5 and P1 will be 18, which is higher than the 17 I had before, right? Why? Well, what drives this price is the fact that I want to avoid that the rich are traveling second class. And it's now easier to avoid that since second class has now become more lousy. So what are my new profits? My new profits from the poor plus profits from the rich are 20.5, which is higher than the 20 I had before. So in other words, by making the lower class, the second class, worse, I can increase my profits. I explained this already. It relaxes the incentive compatibility constraint of the rich in technical terms. You can charge them a higher price. They are less tempted to travel second class. And if you would do a full analysis beyond the scope of this course, you can show that indeed the quality for the poor will always be lower than the socially optimal. So that dates back to this whole analysis dates back to Dupuy, a French railroad economist in 1849 already. And he did this analysis purely verbal without any math whatsoever. But his main conclusion, which is a very neat quote, is that, well, what the railroad company is trying to do is to prevent the passengers who can pay first class from traveling second class. It hits the poor. The poor are now worse off. They get lower quality, although the surplus is zero. Not because it wants to hurt them, but to frighten the rich, right? And that's indeed exactly what's going on. So the next time you travel by airplane and you're thinking, why do I get these lousy leg space and this lousy quality? Well, it's not to hurt you, but it's to keep the rich people from traveling tourist class, right? Okay, that's all we have for this week. We will see you starting Monday at the tutorials and the next live lecture Wednesday at 3. See you then.